Yeah, good to see you. Good to see you, Oleg. Hi, Jean.
Yeah.
Hi.
And then we have the V-Robots team, Rostislav, Oleg, Alexander,
Yeah.
Andrei, and now we have Chen just joining. And hi, Donna. Lovely to see you as well. So this is the second session. I'm really excited about this. And I know, Tim, you work with V-Robots at the moment. Is that right?
Yes, in a sort of a user capacity, but I'm here to support them with a user case scenario.
Great, wonderful, wonderful. Well, I'm excited about today.
Me too.
I see your recording here, so it's 2 past. I'm going to wait just 1 more minute, see if anyone else joins. I'll do a little intro, and then you can take it away. Okay?
Yeah. Okay.
Wonderful. Okay. Just give other people a chance to join still. And you can see in the top corner that this is being recorded. We're hoping to upload this to our YouTube channel to share this with other people who might want to see it as well. Wonderful. Okay. Yeah. Well, it's 3 past. If people join, do they join muted, I think? Is that right?
No, you have.
They can choose to join.
Mute and mute, yeah.
Right. Okay.
And use
well, we're going to start.
Welcome. Yeah. Sorry.
Okay, lovely. So, first of all, thank you, V-Robots team, for joining us with the Univirtual Experience. This is another Univirtual Experience event today with V-Robots from the Ukraine. Is that correct?
Yeah.
Fantastic. We had an event 1 or 2 weeks ago, which is very interesting. But before we get into this session today, I want to say thank you to our supporters and sponsors, in particular HP Virtual Reality and HP Higher Education, our Infinity sponsors, with their brand new Omnicept Reverb headset, which is ideal for higher education. Then also our Galaxy sponsors, the Engage platform. It's been very, very supportive of this, of us over the last year, and in particular this conference. Also Avantis Education, who make fantastic K-12 products and services. We have GroveXR, our stellar sponsors, the VR Lady, the one and only Donna McTaggart, who's here with us today, who is founder of Let's Meet in VR. She's also our event manager and director, and runs her own events as well. So feel free to get in touch with her. Frame VR, LearnBright, Waking Dream, LBX Immersive. How lucky are we to have so much support? And then we have a team of videographers led by Tony Cube Studios, with Fox, Cal, and Brent, who've been doing amazing work. And with that, guys, I'm going to hand over to you. Thank you so much. How are you? Yeah.
Thank you for the invitation, Daniel.
My pleasure. Okay. Where are we going to start today?
So, okay, I think we start our presentation. First step, our presentation. It's small presentation.
About project itself.
Yeah, it's project, yeah. And the second step, we demonstration our product,
Yes.
and we broadcasting our screen and demonstration how this work, how teacher provide online lesson and management virtual reality class. So I think I'm start sharing my screen and demonstration presentation. So share. So you see my screen, yes?
Yeah.
Rostislav, please start.
Yeah. So a few words about how this project actually started and why we are doing this. So the next slide, please, Alec. So the whole story started about 3 years ago in a private school in Vendor. It's also the chain of the robotics studios, the same brand. Was situated in Ukraine and provided courses for the students from level from 6 till 14 years, basically. Now it's expanded more even for the 16 years. So we collected a lot of stories from different age groups, how the actually robotic education was done in our school, and what was the results and limitation of such teaching activities. Now, by the way, the school is expanded in the USA market and Canada. So next slide. So why we actually started considering doing such app for the purpose of teaching. Yeah, thank you, Oleg.
Yeah.
So first one, of course, if you have some robotic studios, you, even if it's a chain, since it's still only linear laws about the expansion of such activities. So because you have the limited number of teachers, some facility, and you can accommodate students in these classes and need the time to provide course during the year. So basically it's about the and then going to the practical exercises in this field. And the first limitation was the time teachers and coaches spent on novice student for construction and assembling the robotic sets, because actually there is a fun not start, because if you have some child with no proficiency, even with handling some mechanical sets, it still require need many efforts and time just to explain how this part should be assembled and wired properly. And you cannot expect that a student will demonstrate such abilities. You need to assist him in his first step, and that actually the problem, because you cannot distribute effectively the time of the teacher between all the students. Somebody is always suffered, and that's a hard trade-off for each robotic studios. So the limitation was actually how to distribute the time of the teacher between the students that had only started this robotic course. And second one, it's of course investment for the any school and studio in physical sets. So it's expensive, and you must to count how many sets you need to provide to the specific class just to be sure that every student can be organized in the effective group of learners, and they can follow the curriculum. And if students are working in a group, there is always a place for a mess, since it's still a kids, and they not necessarily can be focused in teaching, because actually the mostly parents are pushing on kids for these courses as optional or additional learning activity. And that's why we actually started considering how we can overcome these constraints. Some facts probably is already displayed as a statistic. It's not maybe so new for you, but why we believe in importance of such tool for introducing robotics in the school, because actually there is a need for professionals in this field, and its gap is still growing, because number of students that will apply for engineering, math, and science in colleges and universities is not growing, and you need to grow from the school such a pool of talents. So the next, please. Yeah, so basically we solve the problem of the professional orientation. So back please, Oleg. We believe that with our solution, we can allow child to choose themselves that they will love to study robotics, not but because was a push from the parents or a nudge from the school, but because it's a fun, it's not boring, and it's not complex subject. So it's basically about growing the future engineers. So next one. That's our mission. So again, project started in 2018. The first launch of the application was same year at the Go platform, and then for the Oculus Quest next year. Up to 50,000 users has registered in our system, and feedbacks was pretty encouraging. Next one. So what kind of problems we can solve with our application? First one, it's about the collaboration in virtual space, because that's again about the effective distribution of the teacher time between all students. So collaboration means that you can track effectively what each student doing without necessarily just to be present and literally present beside the student. So we can do it remotely. That was the first milestone we want to achieve. And another one, it must be pretty simplified and intuitive game interface that even student with first experience in a virtual reality can easily follow the logic of such course. Next one. So we can organize a class in 3 ways. First one, it could be the traditional class where the headsets is distributed between students and teacher is present in the same location. Second one, that physical class accommodates students, but the teacher with necessary set of skills and knowledge can join this class remotely. And the third one, when the teacher can be present as well as students in a different location across the globe. So like most useful for the private tutoring classes or organizing the fully remote. But anyway, why we need this collaborative tool? Because actually from the first lessons we learned after launching the self-contained application, whereas students were playing just in their virtual headsets, teacher had no idea what actually happened inside the interface, if they are doing right things, if they just stuck or doing nothing, or even trying to play something else. Okay, next one. The last year, when the quarantine started across the globe, we actually find that this remote, enabling the remote teaching could be pretty useful, because suddenly learners and educators were cut off from the physical contacts. For those students that have ability to have such hardware at home, it actually a chance just to be in touch with educators they are used to have. So for robotic studios, it actually was not case, but we consider it like a solution for the mass market, because the only, even for the last year, it's about the 4 million Oculus Head Quest was provided to the market. Next one. So we develop a set of lessons. It's about 16, the total number, each one about the novel robot, some different missions and different bunch of sensors and engineering tasks. Starting from the basic one and assembling a small number of parts, which is simplified simulation. Student can go to the more increased levels and basically assemble a robot from the very particular and small parts, learning at the same time what is the architecture of this set without physically handling these small parts. But when they witness them in reality, they can easily associate and do the same. So from a past experience is doable and reachable. Next one. Our virtual class can accommodate up to 20 students, and we also can allow join to this session not only the teacher who organize class and have the class management tool, but also like observers or spectators, so they can be tied to the teacher and follow during the class to the different location. Next one. Okay, probably we are done with the general overview, I believe, of our solution, and now must have to switch to the presenting the product itself. So probably we can launch our application and show how it actually happens for you.
Yeah. So is this stop?
Who's supposed to be the teacher? Me?
Yeah.
Sorry. Sorry. While you're launching the application, just one or two questions about your presentation. So
Sure.
For me, it's I want to check about the remote application. Any teacher anywhere can teach any student anywhere.
Yeah.
Yeah, that's actually was the purpose, to allow remotely connection between the teacher, educator, and his students, either in virtual, they are in virtual space or physical location. So
Yeah.
our application is just a proxy.
Yeah, yeah. Fantastic.
I think it's fair to say, Daniel, that Chris Long's ambition for having, the borderless classrooms is all about that concept of being able to teach anyone, anywhere, anything. And I think that's a great thing for his memory, that guys like Oleg and his team are coming in and coming with these applications that are just blowing
Agreed.
everything out of the water.
Agreed. Yeah, agreed.
Yeah, and the final notes, we do not consider our solution like a substitute for such classes, but like a primer or teaser. We just want to get students interested, keep this engagement on a high level, because actually the dropout rate is a common problem for each robotic school. So
Yeah.
you have, let's say, the first 3 to 5 lessons, and probably it's like a threshold after which students are disengaged, and only ones that really love this subject can continue the education. And we actually help to overcome that valley, because we provide immersive experience, because we are actually, it's immersive itself.
Yeah.
And keep them engaged. And another advantage actually is that during the class, student is contained in this virtual headset and not have distraction factors. So you can be sure that because kids are kids, that even in organized groups, they still have a limitation just to be messing with each other. And I can do it only in virtual space. Okay.
Well, I'm hoping I'm going to be able to share some of my experiences with you as well, because Alec wanted me to just mention a few things that we've been doing at Broadstairs College, which actually will tie in with exactly what you've just said.
Sure.
Lovely. Ideal.
So I can start sharing my screen and launch the application.
Yeah.
Just a moment. Yeah, I have such option. Oleg, can you enable participant like me to screen sharing?
Please. Please try it now.
Yep, it's working. Just a moment. Screen. Okay. So, here we start again. Just a moment. So we have our product already available on a direct download for Microsoft Store. Just a moment, probably my internet connection is not stable for some reasons.
You do have a lot of applications running.
Yeah.
Yeah, the same. So
Roslav,
I'll
please
launch it directly.
Please stop your video. Not sharing.
Probably is have a conflict in
I can edit it as well, Oleg, when we upload it.
Just a moment. Okay. So we have a starting page of this Microsoft Store, whereas our application available, so it can be retrieved here. Actually, I already downloaded via direct link, and how can just launch it. Do you see the blue starting screen?
Yes, yes, we can see that.
Sure.
Yep.
Before launching any lesson, teacher supposed to create in a CRM system a unique PIN code, which is associated with a new lesson. This PIN code is distributed between the headsets of the students. Somebody to have to support students, or they must to provide this PIN code in the Android application after initiating this session from the teacher side. So I'm providing my name and the PIN code. Which one I should use?
1, 2, 3, 4, 5.
Okay.
Very
Let's
simple.
do it. Going there. So here is the starting screen, where the set of lessons is displayed. The total is 16. So basically you see the icons and which kind of robots is assembled and must be programmed by students. So each one about some different bunch of sensors and missions. We're starting from the very simple Johnny bot, which is just a chassis, brains, sensor head, and manipulator. So now we are inside of this our presentation hangar with the starting point for all classes. This place is used for introducing the subject in the presentation, aligning the class, and collecting them again from the individual learning places if necessary. So you see the table. Now the first student will appear. At the moment, we can provide you only one student, which will be the Oleg, but the total class can accommodate up to 20 students with on this, yeah, you see the alien. So we allow the students to choose some funny avatars that just to be a little bit fun. So you see the table, which can accommodate up to
Oleg? Sorry, the avatars, is that new? I haven't seen that before.
A student have choice more avatar. It's magic, magic animal, it's magic heroes, and other
Lovely.
positive hero. Yeah.
Yeah, fantastic. Okay.
Yeah.
If the number of students exceeds the 7, so additional tables will appear, and it will be up to 3 tables. So student is seated firmly at his place and cannot move across the class just to avoid the mess, because we realize that children like to just going like free electrons. So we have a big screen for presentations, the content, and a small tablet for each student just to duplicate this content which is broadcasting. Yeah, so as a teacher, I can operate this screen and start my presentation. It's now at the default presentation about virtual reality, and the first part. And the second part, we explain actually about some concepts for robotics. What is a robot? What is the parts, architecture? What is required just to make him move and be alive? So this presentation can be updated according to the teacher preferences. So some custom presentation can be uploaded. So here is the interface of this class management.
So that's one student.
We have now only the one student, Oleg.
Yeah.
So if I click on this button, I see his profile. At least I know he's Oleg, his age, his avatar, and photo can be also uploaded. Here is a dashboard for tracking his activity. So I can assign him for this basic mission, which is assembling. So assembling, we have two modes: basic, like easy, and advanced. So difference is because of number of parts that must be combined together. In assembling easy, it's up to 10 parts, and advanced could be 50 or even 100 depending on the complexity. So it influences the time for the assembling, and if student can effectively manipulate the controls and is already accommodated to the virtual reality, we probably should allow them go to the advanced mode. But for the purpose of presentation, we do it like easy. So student is already there, and if I want to join his learning phase, I'm also going there. Just a moment, probably I didn't send him. Oh, I did.
Yeah.
Yeah. So what you see now, his personal place where he started assembling the Johnny bot. So we do not focus on particular parts. It's like big parts combined together. And what we really want from this lesson, just to make students familiar about how this part should be combined, in which order, and actually we reduce this redundant and boring part of assembling a physical tool set. So in the, do you see this funny hat? It's a virtual assistant. So virtual assistant actually provides instructions for the student, and if he follows this, he can successfully accomplish the mission. Each instruction is duplicated by text and voice messages. A student can hear, but teacher cannot actually increase this noisy environment. So now this virtual assistant, it's like a rule-based, but we can also add some intelligent agent and make it more immersive in organizing chat between virtual assistant and student. So student can ask him. So chassis, two parts, brain, two manipulators, and so on. Yeah. And after accomplishing this stage, student is automatically forwarded to the next mission, which is the coding. So at this stage, we can teach the student with no proficiency in using the visual programming language Scratch. So we don't use anymore the specific EVA 3G. So we switch to more Scratch.
Rostislav, sorry. Now it's your broadcasting. It's very, very, very low. It's stopping. Maybe I am sharing my screen with virtual reality. We continue our conversation.
Yeah, let's try that. Good idea.
Oh, it's downloading. Stream.
Just while we're waiting for that to happen, if somebody wanted to have a live VR demonstration, how would they do that?
Yes, if some problem on my side, let's allow Oleg to.
Yeah, I share my screen. Rostislav. You hear or no? Just slow.
Yes,
Yeah.
I'm
Yeah.
reconnected.
Okay. Yeah. So it's Google Chrome. I'm sharing. It's Oculus.
I think Daniel, once you launch the product and you're in I mean, it doesn't have to be in Zoom. You can actually share it through sort of any VR environment. I think then it's just a case of going in and demonstrating it, which is what the guys are trying to do now. Just that there's a bit of a flaky internet connection.
Yeah, sure.
But I know the guys have demonstrated to me before, and I know they've done it in a previous session for Uni Virtual.
Mhm.
But I think, you know, once you've got it streaming in Quest or Quest 2, you can then stream it across whichever platform you then happen to be in, as long as you're sharing your screen.
Yeah, sure. I think the casting is obviously a great option. In a ideal world, we would all sign up as students and actually get hands-on.
Yeah.
In terms of an experience.
Yeah, I think that's probably the next step, to be honest.
Yeah.
Because I think the thing that I've noticed with a lot of VR environments and a lot of VR applications, the problem is always bandwidth restriction for the people who are joining and the people who are demonstrating. All you need is one glitch, and it causes a problem.
Yeah.
That's actually why we started to develop application, because broadcasting from the single headsets doesn't solve the problem knowing what is going inside each one.
Mm-hmm.
So
yeah, that's why you need that management system.
Yeah.
Yeah.
So programming table, and we limited ourselves just for no more than 3 blocks, just to introduce students to the basic concept, what is the visual programming, what is the variable, how they are changed, and what is actually required to do successful programming.
Yeah.
To do this, click on the highlighted block in the bottom panel.
So now you heard voice.
Great.
Yeah.
This block accepts values in the range from -100 to 100. To continue, set power left engine to 100.
And Eva explained for student how explain programming settings.
Now do the same thing with power of right engine.
For Scratch.
Perfect. In this program, block 1 rotation means 360 degrees spin of engine shaft. Set 4 rotations. Super. Now let's run. Congratulations. You have successfully completed tutorial for this block. Now let's check your skills in the field.
So student complex.
In this task, the robot should reach the checkpoint shown with green arrow.
Learning,
to do this, it should move forward for 7 blocks. Let's try to solve this.
Education level.
Add program block.
Now it's education level practice, and student need programming robot forward to green point. It's first task. Second task, programming robot to back forward, and third task, need programming robot to this point and turn right and forward to green point. So if a student have question for teacher, student press button and call the teacher, and teacher see this request for menu and profile student red 1 or red 2.
After accomplishing this broadcasting from Oleg, I can again do it from the teacher desktop and show how this managed.
100.
Mm-hmm.
Awesome. For actual movement in rotations mode, you should set the actual rotations value. Let's try 17. Perfect. Now let's run our program. Press start button.
So the whole idea is that with this simulation, you actually can play and do not spend time on
Now let's go ahead
on
for
unnecessary actions. Just focusing on the core.
values of both engines to -100.
-100 power left and -100 power right motor.
Press start button. Excellent. The robot reached second checkpoint. Now let's learn how to turn the robot. In this task, the robot should move forward to the crossroad, make a 90 degrees turn right, and continue moving to the checkpoint. Set the power values of both engines to 100. Set rotations value to 11. Great. To turn right, you must add another program block. Set power value 100 for the left engine and -100 for the right engine. And finally, set rotations value to 1.
So second block, it's turn. It's different
Perfect.
power.
Now let's add another program block, since robots should move forward to the finish. Set the power values of both engines to 100 and rotations value to 6.
Okay.
Super.
So if student programming block not correct power or not correct rotation and push button, robot forward to base and start.
Oleg, could you turn the headset volume down a little bit? It's coming through very loud and your voice is coming very quiet.
And now,
I have to wait for some sounds to happen.
I think it's duplicate because it's
Maybe.
work Zoom and work our application.
No,
Okay.
I actually muted inside the voice application chat.
Okay, okay, there you go. Thank you.
Roslav, please send student to next education level to quiz.
Sure. So the last step is the quality assurance session.
Let's remember from the lesson. In these tasks, you will need to choose one right answer from 3 options. Please select image with virtual reality headset. Good. What is robotics? Great. What is robot? Good. Please select the main parts of the robot. Great. Please select manipulator. Great. Please select servo motor. That's not correct. Try again.
It's a mistake. So please repeat
Please
again.
select servo motor.
Servo motor.
Perfect. Please select processor.
Processor.
Please select sensor. Perfect. Please select program block, which is set to 6 rotations. Great. Congratulations. You have finished this lesson.
So, and I'm moving to presentation engine, and
Probably I'll start sharing my screen again.
Yeah. So stop sharing. Yeah. Downloading.
Oh. Did I done something wrong? Oh, okay, I see. Here is a presentation box, and here is the student. So just you see this progress bar, and I can track the progress of each student and number of attempts, unsuccessful attempts, and the time spent on each task. This way I can realize if there was a problem with a particular student during the learning session, and we have also the statistics collected and represented for the whole class and a district if necessary. So from the first step, we can easily understand which students have the aptitude and ability to lead this class and help to their peers
Okay.
in this learning.
Okay, just a little bit aware of time. So seeing how this works, seeing that there's now 2 students in there and how our teacher can control it. I would like to hear just briefly from Tim, because I know he has ideas about this. And what I need to say is that in 5 minutes hard,
Sure.
myself and Donna will have to leave. We have another event starting, if that's okay. Donna, if you want to go ahead, I'll see you there. Yeah, so, and before Tim starts, maybe, would it be possible, anybody's interested, could they get in touch with you for a live demonstration? Is that a possibility?
Yeah, I provide our site, and if participants want to try out our application, it's
because that's the most powerful thing. If somebody can actually put a headset on and feel what it's like to be a student and or a teacher, that would be best. But maybe Tim.
I'll keep it very short. I've only got a few minutes. I mean, actually, what you've just asked about, Daniel, is something that I've already done with Alec and this team. So yeah, it's definitely a possibility. My name is Tim Jackson. I'm the program director for undergraduate computing programs at Broadstairs College, which is in Kent, in the United Kingdom. And essentially, one of the modules that we teach on the undergraduate program is robotics. And the college invested £6,500 in Lego Mindstorm physical equipment a couple of years ago, literally just as the lockdown started to come into effect. So we've not actually used the physical resources yet, which has been a problem for us because we've been trying to assess the robotics unit, but not being able to use the physical kit. And that's really when I came across Alec and his team. And it was just by accident that I found them. And had we have had the V-Robots equipment back then, sort of 18 months ago, then our assessment would have been much easier because we're using Lego Mindstorm physically, and we had literally the first practical lab yesterday. And yet Alec and his team are using Lego Mindstorm in a virtual environment. So, and I can tell you now that having started the practical labs yesterday and having had some experience of this program in virtual reality, there's a real similarity between them. And it is quite interesting to draw conclusions between students acting in the real world and those acting in the virtual world. And my plan is that for the next 2 to 3 weeks, we're going to be doing some physical, practical labs. As I said, the first one was yesterday, and they had an amazing time. The first thing they asked me was, can we do robot wars? Which is interesting. Of course, as long as I don't set fire to anything, we're fine. But then I want to take them into virtual reality and say, well, okay, let's emulate the same thing, but in a virtual sense. And I can already see the similarities between what we've been doing in the physical practical labs and the virtual practical labs that Alec and his team are promoting within this application. So I can see some real applications for higher education. I can see how we can use it to promote the development of robotics. But what's quite interesting, the lads that I'm teaching are, 18, 19 years old. But actually, I can see that the way that this has been constructed, you can actually aim it at a younger demographic as well, and actually try to inspire them to get involved in robotics at a much earlier age, which is what Jean and I were talking about earlier on. Excellent. So, I see this has got real legs, or tracks, maybe.
Or gears.
Or gears.
Yeah, probably the single limitation is just recommendation from the headsets manufacturers that it's allowed to start using from 8 years.
Yes.
Yeah. Yes. That's very true.
And of course, you've got the restriction with Facebook. You're not allowed to have a Facebook account until you're 12 or 13. And if you're using Quest or Quest 2, there's an age restriction there. But I think under controlled educational environments, there are ways of being able to get around that.
Yeah.
Sure, but we will add the support for other platforms, not just Oculus. Oculus was used just for demonstration purpose.
And
yeah, of course.
And Oculus presentation 2 weeks ago, subscribable model. If you want use Oculus, not connect your Facebook account, you need to buy license. It's a license for a year. It's not personal. You use only email. It's not connect Facebook. Yeah.
Yes, understood.
Yeah, that's for the consumer unit.
Yeah.
Well, thank you very, very much, V-Robots team, and Tim today as well. Thank you so much.
It was good to meet
if you look at the chat, they've put their email address there. Anybody wants to have an actual demonstration with them, I've done it myself. I think Tim's done it as well.
Yeah.
It makes more sense when you're actually trying it out. And if you have students or kids who you think want to be engineers, this is the future of becoming an engineer now, robotics. So
for sure.
Again, thank you so much from Educators in VR and the Virtual World Society for doing this event for the Univirtual Experience. And I will be following your developments, Oleg and Rostislav. I wish you the best of luck. I hope you get lots of interest and that you continue to develop your program.
Thank you for this positive feedback, Daniel, and thank you much for this invitation and this great audience.
Absolutely. Maybe we'll see you again in 1 year's time. See where you are.
Yeah.
Okay. Thank you so much, everyone.
Thank you, Daniel.
Thank you.
You're welcome. Remember to look at the website, at our calendar. We have about 9 days of events left on this Univirtual Experience. Lots of great events still to come, so do have a look there. Thank you. All right.
Thank you to all participants. Bye.
Thank you.
Yeah. Bye-bye.
Bye.
Take care.
So it's stop recording.